Hello, everybody. Welcome, guys. I'm Piotr Kaluzny, one of the INE instructors. I'm gonna run this session for you. Today, specifically, we're gonna take a look at several things. Since I understand that not all of you has some programming experience, and maybe some of you didn't have a chance to work with APIs to program, to write your own code. I'm gonna make an introduction to the APIs in the beginning of this session. I kind of like to make sure that we are all on the same page with what an API is and what is it supposed to do, how we can use it in our network to communicate the different systems. So this is what I'm gonna start with. Now, then we will take a look at one of the, I would say, supportive tools called Postman. The Postman is something that we will be able to use to test an API, like when you work with a new API of a certain appliance you haven't been working with before. Now, this tool is going to help you to learn this API, to understand the API syntax and its options. Okay, then we will get to the main portion of this session, which is where I will want to show you how to create a simple Python script we will then use to connect to the FMC in order to collect some data. And of course, this script is gonna be talking via the API. It is gonna use the API of the FMC to obtain this information. The script is going to act as a client, and then the API of FMC is going to act as a server in this communication. We'll finish with just a quick look at two of our courses, since this is going to be more of like a high-level session, a high-level introduction to APIs and Python programming. Now, we will just look at things that I think are critical to really get as much as you can out of this session. If you want to obtain some additional information about other supportive tools, about Python, about security APIs other than FMC, some more advanced examples, you will be able to find this information in these two courses that I will eventually present you at the end of this session. Right, I'm going to start with APIs, as I said initially. An API, which is application programming language. API is basically an abbreviation. It's a short. This is more of like a piece of software that we can use that is designed to allow communication between the systems. Between the systems that, of course, are running this API, which have this API installed. You can think of that more of like of a language, common language, the systems must understand in order to communicate. And now the reason that we will want to use APIs for communication is that they have one main advantage over the other communication methods. Like when you say telnet or SSH to the device, you run some commands, you get the output. Something like this you can easily code into a script, but there is going to be a major difference between doing this and using an API. An API provides access to structured data. Structured data is information that is organized in a certain predefined way that you can easily access and modify if needed. And this is also something that you will be able to get to pretty fast in a reliable way. It's a pretty low, I would say, CPU intensive. It's not really CPU intensive method of accessing information. Since the data is organized, it's loaded into memory, you will be able to easily modify, read this information, read this data. I'm gonna show you a quick example of what I was trying to tell you. Let's say that um, we have a bunch of devices. I will just use a single router. That's gonna be sufficient for this explanation. But let's say that the goal is gonna be to write an application. You wanna automate a process of getting the information about the interfaces of your network devices. And specifically, we want to take a look at an iOS device. This is an iOS router. We will write a script. You want to write a script that is going to telnet or SSH. So this is going to be an example of how you could automate a process of getting certain data from your network equipment, but without using an API. I'm going to telnet SSH. Actually, it's going to be my script. It's going to telnet SSH to this router. And let's say that the goal is going to be to come up with an output consisting of two pieces of information from this router. It's going to be the interface name. And let's also say that we want to correlate this interface with its MTU. We want to build a list of interfaces of this device, and we want to know their configured MTU. So we telnet, we SSH, the script telnets SSH, and one way of solving this problem would be to issue the show IP interface command. Of course, if you do show interface, plain show interface, we see we get much more information. Okay, we get the interface and we get its MTU, but in addition to that, we've got a lot of crap in between. It's a lot of junk that we don't really care about in this situation, because the goal is just to get the interface and the MTU, the single mapping. So we don't need to know this. We don't need to know that. This is not needed in our case. That's problem number one, because we will have a lot of interfaces on this unit. So instead of sending the show IP interface command to get this output and then parse through it on the script side, we could cut it down over here. We could send show IP interface, let's say include a gig, and then let's say include MTU as a second command. And we still have some junk to sort through. Like, I only need this portion. You see, we have 3 interfaces in this case. So I would have to cut down on this data, get rid of those additional pieces of information that we don't really need as of right now. And I would have to cut down on the bytes and also this portion. I only want to know the interface name and the MTU. So I would want to come up with Giga1. In this case, it would be Giga1 and let's say 1500 based on this output. I would want to get Giga2 and then 1460. And finally, my Giga3, we see it. This one's associated with 1400 bytes. This is the output I want to get from my script. Okay, if we were to kind of like try to simplify this at that point, I may want to try to do something like this. So we issue one command, we get 2 pieces, all pieces of data we need, but we still have some junk that we will have to remove. So what it means is that your script would have to parse this information. You would have to use some sort of regular expression, write this expression, and make sure that it catches your interface and then the MTU. Of course, it doesn't necessarily have to be the gig interface what you will have on the router. It could be fast Ethernet. It could be something else. It could be management port. So you will have to pay attention. You will have to make sure you write your script in a way it catches all those possibilities, which is typically a place where people make mistakes. It's very prone to make mistakes when you approach things this way, because you have to think about every single situation, every single output you can get from this device. Nothing to mention about any communication problems that may happen somewhere in the middle, like you lose connection, or maybe there is some sort of additional latency that causes the script not to get all of the data, or even worse, Cisco changes the iOS, it modifies the show IP interface command. You have to write another script, or at least update the one that you have to make it work. You've got another device like iOS XE. You've got the ASA. You want to get the same information, you will have to write different scripts. I'm not saying that the API is going to solve a problem of having different platforms or just platforms coming from different vendors, but it could. It could if those vendors, or at least one vendor, would come up with a single API, install it on all of those devices. Remember, an API is just a software, and expose a certain functionality of those devices through that API. This is not going to happen. It's not happening today, unfortunately, in most cases. But at least you have that option. Like if they wanted to expose just a core functionality, core components of the underlying appliance, they could do something like this, and it would simplify things on our side. But this is, again, typically not going to be the case. So we will have different APIs for different platforms. And as I said over here, the main advantage of API over non-API communication is that we're going to get structured data. Okay, so coming back to our example, what is it going to actually mean? What's going to be the difference if I were to obtain this information via API and not just through Telnet SSH to the command line? Well, we have our device. This is going to be our router. And now this time you will install the API on this router. So now I assume that we have this API active, it is available, and we're going to communicate with the API. And it's not going to be SSH Telnet. So depending on the API type, the transport may vary. But in our case, in most cases, it's going to be what is known as REST API in case of network devices, where a REST API works over web, HTTP or HTTPS. We will get back to this topic. Now, I'm going to leave the transport for now. I will just say that this is our script. And this script is going to act as a client in this API communication. Okay, so API itself is going to act as a server. Now, our router is still configured with those interfaces. And from a high-level perspective, the way that we will now get the data, those interfaces from the router, is that the script is going to talk to the API itself. So we will make what is known as an API call. An API call is basically a request generated by the API client to the destination, to the API server. So we will send a request, which is a query. We say we want to get access to the interfaces and the associated data on R1 via this API. Okay, so the API, once it gets the query, it is going to internally access the R1's interface information. And a great thing about this API is that we don't really know what the API does in the background to get this information. It's the API's role to make it work. The implementation details of that are not important for us, for the developers. Our program doesn't have to know how to get it internally. It only makes the API call. Now, as a result of this call, the API is going to get the data, and now it's going to be the destination, the server, that's going to reply to us. And it is going to include this data, in this case, the interface and associated settings. And now the most important thing to understand is that the data we get from the API is going to be, as I said, structured information. In case of REST APIs, it's going to be either JSON or XML. JSON or XML are data formatting technologies. So this is what makes the data look structured. But on the script side, as we will see at some point later in this session, we will still have to convert this structured JSON to a structured Python data, such as a dictionary or a list. But this is not important at that point. We get the structured data, what it means. Well, it means that when you get this information, you will then associate it on the program side, you will associate it with a so-called variable, which is a container for information. And the variable has a name. The name identifies the variable. I'm going to call this variable IFS, or interfaces. So this is a pseudocode, what I'm showing you now. But hopefully you get the point. I assign this data to my variable called IFS. And now the IFS now gives me access to the structured information I got from the destination API, which means that if I wanted to get a list of those interfaces along with the MTUs, I would cycle for this IFS data using special Python code. It's not important for now, but the part of the code would be similar to this. You would say IFS dot, again, this is pseudocode. It's not real code. But you would say something like this. You would say that IFS dot giga1 dot MTU. I want to print it to the screen. You want to get MTU of the second port, you would say IFS dot giga2 dot MTU. If you want to modify the MTU on giga1, let's say, you would say that IFS dot giga1 dot MTU equals to whatever the new value is. Now, if we were to do this using the old style approach with command line, you would have to say interface giga1, hit the enter key, and then say IPMTU equals to this new value. Of course, this is a simple example. The configuration change is not really complex, but hopefully it shows you that unified approach to handling structured information and this ease of making changes and also reading the information we may want to get from the underlying system through the API. As I briefly highlighted, one of the most popular API technologies is called REST API. REST stands for Representational State Transfer. The reason this is a popular REST technology and is going to fit into our case into networking programmability is that REST APIs, they use HTTP or HTTPS as transport in most cases. Probably 99% of cases plus, maybe even every single case, every single implementation uses web, but in theory, it could be something else. So HTTPS is technically not a characteristic of REST API, but as I said, in vast majority of cases, you will see that HTTP and HTTPS is used to transport REST API calls. Okay, since we deal with HTTP or HTTPS, we also immediately know that this is going to work over IP. And this is going to be the case that the characteristic that we care about because people want to make those calls over an IP configured network. Okay, this technology is also fast, easy to use. As long as you know HTTP, you will be able to use the REST APIs. At least you will understand the underlying REST API behavior. Now, more importantly, what eventually makes an API REST-based system is so-called REST architecture. So the fast, easy to use, okay, it's of course nice to have. HTTP over IP transport, also nice to have. But what really makes an application a part of the REST architecture is what is known as architectural constraints. Guys, I see you have some questions. You're raising hands. I'm not gonna stop and try to answer them because it would kind of like throw me off this whole session, this whole presentation. So I'm gonna leave this stuff towards the end. Just go ahead, type those questions, but I'm gonna leave it towards the end of the session. Just to quickly show you what the REST constraints are. There are gonna be 6 of them. I think it's gonna be this link where we can take a look at REST principles and architectural constraints. There are 6 constraints, or just basically characteristics, I would say, of a true RESTful API system. We've got the uniform interface, client-server architecture. This fits perfectly into our case. Communication is going to be stateless. Cacheability is another requirement. A layered system and code on demand. I'm not going to go over this stuff because it's kind of like behind the scope of this session, but you've got it all described in this document. So what those individual characteristics are. It's just basically what makes the system a RESTful system. For our case, I think what's going to be the most important is just to know that we are going to be dealing with a lot of different REST APIs. So it's good to know, what's the transport, what's the main characteristics, but I wouldn't really go down into a lot of details. Stuff like that is much more important for the developers to make the API, create the APIs. Okay, what is going to be important, the most important for us is going to be the REST API documentation. Assuming that we want to use an API of a certain system, it could be an iOS device, could be an ASA, FMC, Stealthwatch, WSA, firepower systems. All those systems that Cisco or another vendor equipped with an API. In order to start using this API, the most important thing is going to be to understand its syntax. And this is where the documentation is going to come into play. Before you make an API call, you have to know the resource that the call is supposed to attach, because the resource is what will eventually represent the underlying system's component. So we can say that at a high level, an API call is going to be composed of 2 pieces of information. We will have the base URL, which is what makes the FQDN, I'm going to say /IP address of the destination system. So remember, this is client to server communication. When you make an API call, like you use Postman or you use a Python script, this is going to be your client. It must know the API path, full API path, including the base URL, and also the endpoint, where endpoint is what identifies a resource on the destination system. So the underlying systems component, the system is running an API, and API exposes certain systems functionality or just components like interfaces, access to interface data, access to ASAs, security zones, policy tables, and so on. This is what we call resources. And resources in the API's terminology are known as endpoints. Okay, an API path, again, consists of 2 pieces of data. Base URL, which kind of like identifies the destination API itself, and the endpoint, which is what identifies a resource. And this stuff like that is going to be included in this documentation. And the endpoints, they will vary between the APIs. So assuming that you can access, the endpoint, let's say to access the ASA's interfaces, this endpoint is going to be possibly different from the endpoint that is meant to do the same thing on the FMC. The syntax will vary. Okay, documentation is where they also tell you about the supported options, the parameters that you can use as you make the call, for instance, to limit the output, the number of pieces of data you get. You may also want to play with attributes, which is stuff that you will then send to the destination, like when you want to modify the underlying component using API. And of course, they will also tell you about the response structure. So as you get the data from the destination, ideally you want to know how it looks like, so you know how to write a code to access certain data from the response. And there is also going to be a couple other things that the documentation should tell you, such as authentication, if authentication is needed by the system. Okay, we will now take a look at one of these supportive tools, tools that most developers use as they learn the new APIs, or even as they build APIs and test them, maybe debug those APIs. Because Postman is basically a GUI-based application. Now, previously it was part of the browsers. It was accessible as an extension of Chrome, maybe even Firefox. I'm not quite sure about that, but it was basically an extension of a browser. Now it is delivered as a native application, but its function is still the same. It acts as a API, I would say, front end GUI that you can use to test the API and learn the API in general. And it doesn't necessarily have to be REST API, what Postman can deal with. It can be also SOAP and some more API types. In our case, we will, of course, use it to deal with REST-based APIs. If you don't have Postman installed, I would go ahead and take a look at the getpostman.com website. This is where you can get the free of charge version of Postman. And there is also a more advanced application for which you have to pay. For our purposes, the free version is all we need. So we don't have to pay for advanced functions unless you are developing some serious stuff. You want to use advanced functionality of Postman. And there is also a great tutorial on the Postman's website that you can look at if you are new to Postman, just to learn how to use this application. I'm going to show you that this is the Postman installed on my PC. And there are going to be several different portions of the main window we will want to look at. Maybe for now, what I want to show you, the most important thing you want to take a look at as you start working with Postman is going to be some of the settings. So you go to File, you take a look at the settings, and under the General tab, this option here, SSL certificate verification, is something you probably want to turn off. And the reason you want to turn it off is that the APIs running on systems where the communication is SSL TLS protected, the Postman is not going to able to make a call to those systems without validating the system certificate in the first place if this option is enabled, and by default it is. So what we will do in this case, we will basically disable this option, so we don't have to worry about configuring Postman so it can validate the certificate of our destination system. Especially that in my case, the FMC certificate is self-signed, so my trusted certificate stored on this PC doesn't have the certificate installed, and this would break the whole communication. So I would go ahead and disable this option as one of the first things that you configure here in Postman. Okay, then The other things, they will be related to the request you can make using this tool. So click on create request. We've got a bunch of fields we will be playing with. Most important option here for the actual API call is the HTTP verb, the method, which is going to determine what type of action we can perform on the destination system. In many cases, it is going to be a GET. A GET is what you will use for read-only access. If you plan to modify something on the system, it's going to be a post or maybe a patch. It's going to be the API's documentation where they will tell you what method you want resource to make the modification. But as a rule of thumb, whenever you send a GET, you cannot modify anything. It's just for read access, just to collect some data, to retrieve some data via the API. Okay, maybe I'm going to show you the other fields when we get to a quick demonstration. Let's go back to the presentation for a second. A couple useful features, slightly more advanced, but something you can do in this default version of Postman. Collections and environments. This is something that allows you to organize individual requests, API calls you make from this application. Like when you put the URL over here, you say send. You can save those requests for a later time to easily reuse them. So collections and environments, this is technically a separate feature. But again, the idea is that you will be able to collect those requests, group them, and at some point later in the time, you'll be able to reuse them. The parameterization is how you can use variables, how you can implement variables in Postman. A similar concept to objects on the ASA. Like in this case, instead of specifying the full URL every time you make the call, like let's say you make a call to HTTPS FMC1, then you put the actual endpoint. You want to test, let's say, a couple different FMCs. You have to change this URL. So it is possible to use variables inside of this, specify the URL inside of the variable, or just basically store them in a file on an external location and then load, so that when the call is made, it's more of like an automated thing. You don't have to type the URL, the exact URL every time you make the call. You can make it slightly more automated with those parameters. And there is also the great ability of generating some base of Python and Perl code to bootstrap your scripts. We will look at this in this presentation. Okay, before we get to the FMC, and before we start writing some Python code, I want to quickly show you how to use one of the publicly available APIs, just to quickly learn the basics of Postman. There are several websites out there on the internet that support API, that use APIs that you can then test with API client Postman. And one of those websites is httpbin.org. So you download the application and you make the first API call to this website. You just have to know what's the actual API call path. What's the base URL, what's the endpoint? And this is something that we will look up in the documentation. I'm going to say httpbin.org. This website shows you the API endpoints over here. They say that base URL is this. Notice that it contains the / at the end. It's because what's going to follow is the endpoints. So you've got a couple different things as how you can use this website. In general, it is going to echo back the information you sent to it, or it is going to provide you certain information you requested for specifically. Like if I send a GET, this is what makes my endpoint / GET. I send a GET. Okay, so this is my base URL. I put a /, and I use the endpoint from the website, from the documentation. I'm not gonna include any optional parameters. I'm not gonna use authentication. We'll just send a simple API call to this website. The method is set to GET, waiting for a reply. Okay, we got the reply. So let's take a look at this from scratch. As I said, this is what allows you to choose the HTTP action that you make for you want to select for the call. This makes our API path. Remember, this is the base URL and the endpoint. Okay, optionally, I could also over here, like specify the limit of the responses I want to get. I may want to enable, disable authentication under the authorization tab. Okay, the body, which is going to be the content of the message, you could technically, but it's going to be ignored by the destination. The body, it only makes sense to use it when you use post, maybe put. So those HTTP actions that allow you to modify a resource on the destination. On settings, let's take a look at this. It's stuff like handling redirections, like when you get a response that calls for redirection, and some more advanced options. You can configure them here. This is not affecting the, I would say, call. It's to handling the behavior of the application. And then you also have the headers, which is the ability of specifying, configuring some HTTP request headers that will be included inside of the HTTP call generated by the client in the request. Now, as we get the reply, the first thing we should, which is going to be this section. So this is going to be a response versus this portion here is for the request. Now, as we get the response from the server, this is the content, not the content I'm going to leave it for later. The first thing we want to take a look at is going to be the status, HTTP status for this transaction. In this case, it says 200 OK. Whenever it starts with 2, it generally means that you're fine. Okay, how long did it take for the transaction? What was the size of the session? And then we get to the body, possibly some of the cookies, response headers, and test results. This is basically one of the more advanced functions of Postman, so we will not talk about that. But the most important portion, of course, here is going to be the body of the message, which is the actual response. Okay, just one more call to show you the difference. I'm gonna use this website, this API, to download an image. Because what we got in this case for this first call is pretty much it mirrors the information sent to the server. So this is the headers that we sent to the destination systems. It basically mirrors this information. It sends it back to us in the response. We will now say we want to download a JPG image, which means that this makes my new endpoint for the call. I have to change it from GET to image /JPG. Okay, we send the call. It's still going to be a GET. I make the call. We got a different response. We got a different content. It's a different piece of data that is exposed through this API on the destination server. So hopefully it shows you how easy it is to use a REST API with Postman, how easy it is to make those calls, and those publicly available servers, destinations. This is a great way to start playing with APIs, at least in my opinion. Moving on, let's now take a look at the some more complex example. Now we will try to communicate script that is gonna rely on the REST API installed on a FMC system, where the goal is gonna be to collect some data. It's gonna be the a list of objects in particular, what they wanna get via accomplish this using Postman, well, using REST API, using Postman, and then also using the FMC's documentation. I'm gonna start with going to the Cisco docs, because in case of FMC, one additional thing we will have to take care of is gonna be the authentication. I'm gonna go to programming guides, and we will open a doc for 6.2.2. And maybe let me also open a tab where I'm gonna connect to FMC using a GUI, like if we like what we do normally to get access to the system. But this is actually where I'm gonna start. I'm gonna log into the FMC using the GUI to show you one of the main prerequisites of using the API on FMC, which is to enable it. So from the main FMC's window, you'd have to go to System, Configuration. Some appliances, they require you to enable API before it gets active. Down to REST API preferences. And by default, it is enabled, so should be good to go. We are good to go. I also added one additional user account as this is basically one of the best practices that people follow. You want to separate the accounts, the admin account from the accounts used by your scripts. So I build a separate account that I'm gonna use to make the API calls within my script. And if this was a production network, I would also limit the number of writes this user has, because it's in case of FMC, the idea is basically like with the GUI. The script user has access, which is limited based on the roles you configure for the account on the FMC. Now, in this case, the user is going to have the admin rights, which means that I will be able to use this account to retrieve every single piece of data API exposes for the FMC, and I will be also able to modify this data. Okay, one more thing we will take a look at in the GUI. We will go to Objects, and I'm going to show you what we've got here. And we will take a look at the network objects. Okay, this is what I wanted to show. You've got three custom network objects added to the configuration at the bottom here, configured with certain descriptions and IP addresses, subnets, LAN 1, LAN 2, and LAN 3. And I'm showing you this here because this is what we will focus on as we run the script. We'll basically try to find this information in the output, in the data collected from via the API. Okay, good to go. I'm gonna log out. And the next thing we want to look at is the FMC's documentation. Let's take a look at about the API Explorer. Right, so To access the documentation API docs on the FMC, they are stored locally on the device itself, and you have to use this endpoint, this FQDN, this URL to access the documentation. It's going to be /API /API Explorer. Let me show you this over here. We will have to use the documentation at some point. So I'm going to log in as admin. In many cases, the API documentation is going to look similar. I mean, the whole GUI, the look and feel, just based on the fact that a lot of people, as they create an API, they use the same exact framework, such as Swagger, maybe Open API. So the structure, the documentation is going to look similar. Of course, the syntax is going to vary. Okay, it shows us the types of endpoints we can use for this API. When you click on one of the types, it also gets you to the actual, to the full it shows you full endpoint syntax. And for some of those, we can use something else than just a get. Like we can remove a resource, we can add a new one, we can modify, add a new one, or just read get the data or read access. I'm going to leave it for a second. The most important thing as you start working with the API on the FMC is to know how to handle authentication. Authentication on FMC is a two-step process. The first API call you make to the system must be authenticated using this single user account that's stored on the FMC itself. So it's going to be a username password authentication. And the way that you will authenticate is by sending a single post API call. It's going to be an empty call, which means that the post body is going to be empty. This is the endpoint that you will have to send this call to. And as a result of this call, you're going to get what is known as an access token. And an access token is what you will have to include in every single subsequent request. Once again, I make my first call to kind of like open a session window for authenticated calls, for subsequent authenticated calls, and subsequent authenticated, for the subsequent calls to be actually authenticated, I'm gonna include the token in those calls, and the system is gonna be validating the call based on the token itself and not the username and password. So the username and password, you only send it once, and then possibly as the token expires. Right, let's take a look at this. Let's go back to the documentation. And I'm gonna say connecting with a client. I'm gonna go over this once again. Okay, the REST client, this is what's gonna make, in our case, a script. And this is gonna be the FMC on this side. This is gonna be API call number one will be have to send from the client to the FMC, where we do so-called basic authentication. They say that this is HTTP GET. It's not a GET, it's gonna be a post. I'm gonna send a post with username and password. And assuming that I authenticate, I provided the right credentials, the system is gonna generate two tokens, access and refresh. Refresh is used to extend the original token by another 30 minutes. And you can do the refresh up to 3 times. When you did the third refresh, you will have to re-authenticate using username and password. But we will not get up that far. We will just send a single username and password to kind of like open the 30-minute window, and then subsequent calls we will send them with the access token inside, as long as the token sent by the within the call matches the FMC's entry. It is going to give us access to the resource requested in the call for the endpoint. Okay, somewhere here it is going to tell us what's the API path to authenticate to generate the token. So this is what we need for our first API call. I'm going to copy this. We'll go back to Postman. I'm going to kind of like break this whole API communication down into two pieces. We will use Postman to generate a token. And then as I build my script, I'm gonna hard code this token to the script itself so that the script can focus on the data a portion of this call. So we will use the script to retrieve the resources where Postman is gonna be used to obtain the token. Of course, if this was, if you wanted to come up with a script that is gonna work all the time, you would have to include the authentication portion into the script itself. And if you're wondering how to do this, this is something that you will be able to see in one of my INE's courses. I want to keep this session as simple as possible. This is introductory level webinar. So I don't really want to confuse you with multiple calls, having multiples in a single script. This is why I'm gonna use Postman to separate authentication from the data retrieval. Okay, FMC this is gonna be the base URL to get to my FMC 172.16.15.100. And then I want to copy the authentication endpoint, paste it over here, just one /. The forward slashes are critical. If you skip one or you put too many, it won't work. Based on the where is it going to mention that? Hold on a second. This is authentication, requesting authentication. Okay, it says this over here under the procedure. Set the client to make a post body should be blank. This is exactly all we need to know to make this call, to make it successful. Okay, I make it a post. My body is clear. I don't send anything inside of this post call, but under authorization, I will now have to choose basic authentication as my authentication method, and I will have to provide the user credentials configured on the FMC API script with a password. Okay, let's give it a shot. Let's try to send this, make this call. And let's see what's going to be the result of that. Okay, we get a response with an empty body, which I know is fine. This is also documented. This is a 204 response, which means that it is fine, it has no content. But if we take a look at the headers, returned by the destination. It has the access token. It's the exact header name that you will have to include in subsequent API calls. This is the header name, and this is the value. This is the token itself. Now, another important thing that you would get from this output is the domain UUID, which is something that your script would normally have to include inside of the headers as it makes subsequent calls. This is all documented. somewhere here or on the FMC itself. In our case, since the FMC on box documentation includes the domain UUID in the API endpoint itself, we will not have to worry about that because I will copy that from the doc. It's this number here. Every single API call, API endpoint documented refers to this number, which is what identifies my FMC. This is the domain UUID. So it matches what we see here in Postman. Okay, but let's get back one step. This is the token that I know I will have to include in my subsequent requests. So now we get to the portion where we will have to write a script. You'll have to write some code in Python. And this code is meant to make another call to get the network objects. How do we do this? If you take a look at the request portion of Postman, this option is slightly hidden, the code option on the right. It's slightly hidden, but it's actually a great tool that will allow you to bootstrap your code. It's the way how you can generate some Python or Perl code directly from the Postman application. If I click on the code over here, it shows me this is a Python code. I can go for Python, for PHP. Okay, Perl is apparently not here, but it supports a lot of different programming languages or basically methods of generating API calls. You can switch to them if you want. And requests is basically a module, a special Python module, like a collection of code written by someone else that simplifies making things inside of your own script. And in our case, what's simplified is generating an API call using get, post, or a different HTTP action. Okay, I'm gonna copy this to my Python file, and we will discuss this stuff in just a second. This is what was generated by Postman, the additional optional headers generated by the Postman application, and we don't need them. The authorization header over here is basically the encoded username and password. So the API script account with the password I provided is encoded to this authorization header, and this is how we do our first authentication to get the token. Because remember that what I generated here, this code was generated for my first API call configured with this endpoint. This is what we use to get the token. And once the token was generated, I have now a 30-minute window where I can use this token in subsequent API calls. Okay, what do I have to change inside of this basic code? I'm gonna break the URL down into two pieces. I'm gonna say that base URL is what will identify my destination, the API itself, my FMC. And then I'm gonna create object endpoint, which is what we will take from the documentation. Because remember, the goal of my second call is to get, hold on a second, I need to find the right API endpoint, network objects. If you take a look at this, it says that this is the endpoint you have to use to access the network objects. So this is what I want to copy. I'm going to say get. I will copy it from here. You can use this documentation to do the similar thing to Postman. You can generate requests, API calls from here. And there is also to do some actions within my script. So I want to use someone else's code inside of my script because this code was written in a very concise manner. It became kind of like a standard. It works really well. I don't want to replicate it. I don't want to write it from scratch. I want to use it. And this code is specifically what we will use to generate the API call. So requests is the name of the package. And then I use one of the packages, a piece of this piece of code from this package to generate the actual call. The call in this case is set to be post. We will have to change it to get. This is my URL, my API path. And then the headers is what I include inside of HTTP header section. And the headers is what is going to include our token. We will just have to modify that. Okay, printing responses, we will not need it for now. I still haven't finished what I wanted to show you here. Server. And this is my URL, which includes the object endpoint. Now, we will need to include actually a few additional things. Now, one is going to be to disable verification of the system's certificate, which can be done by using this parameter, verify. You want to set it to false. And this is something you could actually take from the doc. Where's the call? Where's the endpoint? Okay, this is my endpoint. I clicked on get to generate this call from the API Explorer. I can also take a look at the Python code that I can use in my script. This is much more complicated than what we saw with Postman because this code includes exception handling, and it also does some formatting at the end, which I will actually want to use to make the output look nice. I'm gonna show you what I mean in just a second. I will just copy that to my script at the end. I'm gonna put it over here. But for now, I'm gonna comment it out, which means that these lines are not active. They won't be interpreted by the script as it is executed. Okay, so let's see what's gonna be the result of this code, of the code modified from Postman. I'm gonna run the script. It says that adding certificate verification is strongly advised. This is just a warning message because I disabled certificate validation using this option, verify equals to false. This is also documented in this code generated by the API Explorer. It says, if you wanna make a call with SSL verification turned off, you wanna include this line in the request. Okay, but the outcome is not what they wanted to show you. Let's double check the syntax here. Okay, I've got my base URL, then I've got my endpoint. And we see that this is specifically for object networks. I included the token. It might be the case that the token has actually expired, but we will wait. Okay, I know what's the problem. I didn't say I want to print. Okay, I want to print the code is fine. I'm gonna save, and we will. So this comment here, it says, show me the body of the response. Show me the content from the server. Show me the API data. The network objects configured on my FMC. But as you can see, this output is, it doesn't look nice. And this happens because it's a single string. It's a single line string of characters, which is not formatted. I mean, technically it is structured data, it's JSON stuff, but it's not formatted to look nice on the output. And that's the only reason why I copied the additional lines from the script and I'm gonna tell you what they do just a second. I will just have to say that rasp equals to response.text. Okay, let's talk about this stuff. Right, so what I showed you up to that point, we know that this requests function is what we use to make an API call. Okay, so this is my script. This is FMC, my destination. I make a call, get request, it collects the information about the objects on the FMC, and it includes this information in a response. And I'm now taking this data and I am associating them with a special variable, with a custom variable that I call response. Okay, so response, it has the data from the FMC. Now to display this data, I'm referring to the text attribute. This is all part of the request module. The text attribute is basically how you tell it you want to display. You tell it that from the data as you take it, you only want to print, because at some point I said I want to print. I only want to print the body of the response. I don't want to display the headers. I don't want to display the status code. I only want to focus on the body, on the content of the response. And this body I then assign to another variable called rasp. So rasp is going to have the body. And now these two lines, the only reason I'm using the JSON module, JSON, this stuff here, this is another package, another module, so someone else's code that allows me to quickly take the response data, which is JSON, and then translate this JSON stuff to the Python structured data. It's going to be a dictionary of what we will get. Because what API server sends to me, it is structured data, but the technology used to represent this data, to format it, is called JSON. Now, if I want to make this data usable on my Python script so I can access this data, modify certain pieces within it, I want to turn it to a dictionary, because dictionary is what Python understands. The Python dictionary is what Python can load to the memory and then easily modify, access. So this is why I'm using the loads function. Deserializing the JSON data to a Python dictionary. And now the second line does the opposite. It takes the Python dictionary and turns it back to JSON. Okay, so why do we do something like this? The only reason I'm doing that is to make the output look nice on the console. I still have to print it. Actually, it actually prints. So it does the formatting, and then the result of this formatting is being printed to the screen. The dumps function is what gives you access to some additional sub-functions that make the output look nice. This is the only reason why we use functions. Okay, to actually use JSON, I will have to import it. I know that it may actually sound somewhat complicated, especially for those of you who deal with Python APIs for the first time. I'm gonna show you. I will give you. I'm gonna make a quick introduction to the other courses that I made that explain this stuff in a better way. Because the focus is just to make this call to show you the output. I'm gonna save. Let's see if it actually works. Okay, now we see that the output is actually nicely separated. Individual objects are separated with commas. And at some point down here, we have our LAN1, LAN2, and LAN3 network objects. And now to show that it actually works, we will go back to the FMC. I'm gonna leave the Explorer, and I'm gonna connect. I'm gonna use the GUI to add some new object, and we will then rerun the script to show you that it actually works, that it actually fetches the current data from the platform. All right, down to objects, then object management. So let me add one more under network. I'm gonna call it LAN4. 10.4.4.0/24, we will save. And then I will log out of that GUI, and we will run the script once again. So let's make it clear. And we see that it got everything from LAN1 down to LAN4. So the script is working. It's getting the data, the up-to-date information from the FMC via the API. The reason we don't see information about IP addresses or descriptions is that the actual call, I will have to show you the Explorer again. We will take a look at this data from the Explorer. what's the okay, so the reason for this is that the actual endpoint, if you wanted to get some more details about the object, it must include the identifier of the object in question. Let me show you this here. Object endpoints, we go back to our endpoint, which is here. It says it allows you to perform CRUD, so create, read, delete, create, read, update, delete operations on network objects associated with the specified ID. If you don't put an ID like what we did, on our endpoint, it doesn't have any ID defined on after networks. It retrieves a list, just a list of all network objects, but without any details. I'm gonna ask for those objects again from here. And you will now take a look at the last one, LAN 4. It is identified with this number. So if I were to put it over here, and we will rerun the call, we will resend it, we will now get the details of this object, including the subnet. Of course, I could include this information. I could put it to my script. I could modify this endpoint or create a new one, then modify the URL, and you would get the same information from the script itself. As I said, we look at a lot of different information in this webinar, and I know that I skipped over certain items. So if you're wondering, about the underlying details, about you want to learn about the Python syntax, you want to learn more about the actual tools that you might want to use along with Python and possibly those REST APIs, I would start with this, a course, Network Programmability Foundation. This is more like a general introduction to programming, APIs, and Python. And then if you are interested in the security automation, I will look at network security automation. In this case, I'm focusing more on the APIs of individual security appliances, including FMC, Umbrella. I'm discussing those APIs, and I am also showing you some of the examples. Okay, let me take a look at the questions you guys had. Which I succeed, I think this one, well, it's going to be either NetConf or REST. This is something I would actually have to look up. It's not the most of the security appliances that I've been dealing with, like the WSA, ESA, FMC, Firepower, StealthWatch, they all support REST. In terms of iOS systems, this is something that I would have to look up. But I believe that iOS XE, it either supports REST or NetConf or even both. Is there a way to retrieve all network objects and details in a single pass instead of pulling each object and doing a new request for each object? Well, this is something that you would have to code to your script. So you would use some sort of a loop, either for or a while. And you would then say that for every single object you get in this list, As you go for this list, tap down. For every single object you process within a loop, you want to print the details. You want to get the ID. You want to take its ID. You want to access the ID within a given cycle of a loop. Once you have that ID, you will print the details for this ID, and this is all configured within this is all written within a loop. Stuff like that, I'm showing you some of this inside of this second course, Network Security Automation. Can we retrieve a structured formatted data out of Cisco devices just using a special show command via SSH? Not with REST, not with REST API. I think that netconf, another API type, netconf is basically, I think that this one is working over SSH. So it's a different transport, but it's still going to be structured data since netconf is actually a type of an API technology, but not with REST. Okay, on FMC, can you show how to get policies and change variables? Okay, this is covered in my second course, Network Security Automation. And just one more question. Has REST come to replace SNMP? Yes, it is going to eventually replace SNMP because SNMP implementation is actually not really consistent across the different platforms. The REST is built specifically, the REST API is built specifically for a given platform, for a given appliance. And it's the Cisco's choice what they expose, and how. With SNMP, I believe that it's not going to work for every single feature component of the underlying system you may want to expose. So the SNMP is not really good, especially when you plan to modify the data. So for reading and writing, the REST is going to eventually replace SNMP, that's for sure. I want to thank you guys for joining this session. I hope you enjoyed it, and I'll see you in the next webinar from INE. Thank you.